I think really the benefit of going through problems like this is if you don't get all the way through it or get the wrong answer, it really helps you identify like what step you're sort of hazy on, you know? So try to pay attention to that. Like if you weren't sure about a step, uh, as I'm going along, try to make it clear to yourself like where things, uh, where you got confused about things. So okay, basically there's a wall. That's too high because I can't. And there's someone standing on the wall. Maybe not standing. Maybe if he's throwing it from the level of the wall, maybe like that. Throws the ball down towards the ground. Maybe the ball has a message in it that's like, send help. I'm trapped up here. That's hilarious. Okay, so what's going to be time equals 0? Yep, the instant it's released. What's going to be time final? Yep, instant it hits the ground. What do you want to choose? So now the next two are sort of arbitrary. Well, for free fall problems, we're always going to choose the positive direction up. So let me just write that. Positive direction up. The 0 position is arbitrary. We can choose that anywhere. The two that make the most sense would be the ground or the point it's released from at the top of the wall. You have a preference? Ground. Okay, so now we're going to list out what variables we know and what we want to find. Do we know the initial position? 10, yep. Do we know the final position? 0, yep. Do we know the initial velocity? Nope, and that's what we're looking for. Do we know the final velocity? Nope, that's the one. That's an easy mistake to make. So remind yourself not to think that at the instant something hits the ground, the velocity is 0. It is 0 after it hits the ground, but at that point it's not in free fall anymore. Okay? So no, we don't know anything about the final velocity, but if we can solve this problem without it, that's fine. We're not asked for it. So that doesn't go anywhere. Do we know the acceleration? Yes, it's a free fall problem. And do we know time final? Yep. Okay, so is there one of these three equations that has V initial in it and everything else in it is known? Second one again. So 0 is equal to 10 meters plus VI times 0.7 seconds plus 1/2 times the acceleration, negative 9.81 meters per second squared, times 0.7 seconds squared. So you get 0 is equal to 10 meters plus, well, 0.7 seconds times VI. That's what we're trying to solve for. What's 4.905 times 0.49? What is it? Okay, so minus 2.40. And the units are going to be, these seconds squared are going to cancel these seconds squared. So 2.4 meters, right? Yep. Yeah, I just carried that along with the 0.7 here. Okay. So now we can subtract 10 meters from both sides, add 2.4 meters from both sides, and we get 7.60, negative 7.60 meters is equal to 0.7 seconds times VI. And divide both sides by 0.7 seconds. What's negative 7.6 divided by 0.7? What, 10.6? Okay, so negative 10.86. We have meters divided by the seconds over here, so VI is equal to negative 10.86 meters per second. Do the units make sense? Yeah, that's what we'd expect for velocity meters per second. Does the sign make sense, the fact that this is negative? He's throwing it down. Our positive direction is up, so yeah, it should be negative. Any questions about that one?
I have a question.
Yeah.
So, like, you had said about the velocity of it, it touches the ground.
Right.
Then it's gonna be zero. But like, one instant it doesn't touch it, it's not zero.
Right.
Like, how would be the question? Like, if you ask any question.
Okay. Well, anything I ask about when it hits the ground, that's really kind of just shorthand for saying what's going on the instant before it hits the ground. And that has to be the case because as soon as it touches the ground, it's not in free fall anymore, and these equations don't apply. You know what I mean? So anytime you're asked for something at the ground, what's its velocity at when it hits the ground? How long does it take to hit the ground? You're really being asked for a kind of what's going on at that last instant before it touches something and leaves free fall. Okay. Yep.
On the exam, do you want specifics of what's the direction that we chose?
You know, if you don't want to do that, that's okay with me. I think for a lot of people who are seeing this for the first time, I think it does help, but I won't take off any points for not doing that.
Because if I were to choose the opposite direction, I would end up with a cosine velocity.
Right. Well, with
Would that still matter?
no, that's okay. With free fall, I would say your positive should be up. I think you're opening yourself up for a lot of dumb mistakes if you're changing around what you're calling the positive direction in free fall problems. So I would recommend just always make that up. But in general, like you're right that you can make these choices sometimes different than the ones I would make. You'd get a different answer, but as long as it's all consistent, that's perfectly fine.
So like, it doesn't matter like what the sign, negative or positive will end up, but the answer is right.
That's right. That's right. That's right. And that's true in free fall too, although like, and I don't want to say like, don't do that because mathematically it's fine, but in free fall problems, I would strongly recommend using the positive direction up. Not only, I guess, for one thing, it cuts out chances for you to make mistakes because you're always doing things the same way. And for another thing, that's just how everybody does it. So it's sort of as a communication between people doing physics problems. It'll just make more sense to someone looking at your work. But I wouldn't ever take points off if you disregarded all my advice, chose the positive direction down, and everything was consistent. I wouldn't take off points for it. But it's on the constant acceleration problems that aren't free fall where you have total flexibility about choosing a positive direction. And then a lot of times people get answers that are the opposite of mine, and those are still right. Any other questions? Yeah, a lot of partial credit. Even, actually, I should probably say, like, in some ways I give a lot, and in some ways I probably give less than other people. Like, to me, if it looks like you're understanding what's going on, I'll give you full credit even if the answer comes out wrong. Like you make some math mistake that doesn't look that significant to me, I'll give full credit on the problem. But if you make a mistake that to me shows a significant misunderstanding of the problem, like there are cases where someone will get the right answer and they get it in a way that's lucky or whatever, and they'll lose most of the points on the problem. But yes, I do give partial credit. Any other questions right now? Okay, here's another one for you to work on. Okay, this is a recurring character throughout this semester and even next semester a little bit. Carousel Kid, trademark. I own his rights. He sits on those playground carousels. He looks like he has a comb over this semester. Okay, so this is him from the side. He wears clothes. Okay, so here's the problem. Carousel Kid is initially at rest. When a bully comes over and accelerates him, to a speed of 5 meters per second over a time interval of 2 seconds. So first, what's his acceleration? And second, what's his displacement? Okay. See if you can work through that one.